Question 1. Expand x plus 2 in brackets times x plus 3. When we expand this, I like to split the first term. Split the first bracket, then expand each section, and then collect like terms. I'll show you what that means. See that first bracket, x plus 2? I like to split that and break it up into an x and a 2 and multiply that second bracket by each of those things. So firstly, I'll take the x from the first bracket and put it in front of the x plus 3, and I'll be expanding through that. And I'll take the plus 2 from the second half of the first bracket and put that in front of the x plus 3. So I'm splitting up that first bracket and making sure each of those items in the first bracket ends up multiplying through the second bracket. Okay, so x times the first bracket there, we get x times x making x squared, and we get x times 3 making 3x. For the second bracket, when 2 gets multiplied through there, 2 times the first term of x makes 2x, and 2 times the 3 makes 6. Now we have some like terms, 3x and 2x there, that are able to be joined or merged. So we'll do that in the last step here, and we'll have a final answer of x squared plus 5x plus 6. So that makes a set of two brackets that are multiplying there end up with what we call a quadratic trinomial expression. Question 2. Expand x plus 3 all squared. We're going to think of this in two ways. Firstly, we'll do our normal expansion, because if you think about it, x plus 3 all squared, a square happens when you're multiplying something by itself. So we can write x plus 3 all squared as x plus 3 times x plus 3. And then we can do it like a normal everyday expansion of two brackets there. I like to split the first term, or the first bracket, and we'll have an x multiplying by an x plus 3 and a 3 multiplying by an x plus 3. I like to do this way because for me it's quicker and a bit more reliable than drawing arrows all over the place. Okay, as I expand the first bracket, we've got an x times an x making an x squared, and an x times a 3 making a 3x. And we have something very similar on the right hand side, 3 lots of x making 3x, and 3 lots of 3 making 9. We do have some like terms in the middle there that can merge. 3x plus 3x will make 6x. So our final answer is a quadratic trinomial of x squared plus 6x plus 9. Now this is a square of a single bracket here. It's called a perfect square, and there is a shortcut sort of format that we need to get to know because some questions are based on knowing this shortcut format by the name of perfect squares. So this sort of says that when we've got two terms that are adding together in a bracket and the whole bracket is being squared, there's a pattern for our answer that we can go straight to. It's a bit of a shortcut. So that involves the first term of the bracket. Our answer will be made up of the first term of the bracket squared. So in this little example here, we've got an a as the first term of the bracket, and it's getting squared to form that first term. Now the middle term is interesting. That is formed by having a 2 out the front and a product of the first term and the second term from the bracket, all merging together in that middle term. So it's 2 lots of a times b. 2 lots of the first term times the second term. That forms that middle term of the perfect square answer. And the last term is just the second term from the bracket getting squared. So if we apply that to our x plus 3 situation, if we have our first term being squared, we get x squared. And for our second term, we have 2 lots of the first term times the second term. So the first term times the second term is an x times a 3, or a 3x. If we have 2 times that 3x, we'll make that 6x straight away. And our final term becomes a 9 because it's the second term of the bracket, the 3, being squared. So if we get to know that shortcut, it'll be quicker, and we'll be ready for those questions that are based on knowing this perfect squares format. So in the end, I just demonstrated to you there that doing it the expanded way that we started with, that gave us x squared plus 6x plus 9. But if you follow that shortcut perfect squares method, you get the same answer as you should, x squared plus 6x plus 9 as well. So there are two different ways to think of that one. Question 3. Expand x minus 2 in brackets all squared. Okay, we can split that first bracket. We'll firstly consider x minus 2 all squared as x minus 2 times itself, because that's how you get a squared, you times something by itself. And then we'll split that first bracket, so we'll have x outside of x minus 2 minus 2 outside of x minus 2. We're breaking up that first term and making sure each of those items in the first term expands through that second bracket. Okay, so when we go in expanding through that first section there, we have x times x making x squared, and we have x times minus 2 making minus 2x. Now here's where I want you to slow down and have a think about this. A lot of students get these wrong here when there's a minus in front of that second section. So that's a minus 2 timesing by x and a minus 2 timesing by minus 2 in the bracket. So a lot of students I see get these wrong because they sort of rush it, or they don't take full notice of that minus that's in between the two sections there. Anyway, minus 2 times x turns out to be minus 2x. Now here's where a lot of students go wrong. They somehow don't remember that it's a minus number in front of the bracket just for this last section. It's minus 2 times a minus 2. Now a minus times a minus makes a plus, and we have to be careful there to get a plus 4. We have some like terms in the middle there that can be simplified. So we have minus 2x minus another 2x, ending up with minus 4x. So final answer in the normally expanding type method, x squared minus 4x plus 4. Now we have a similar shortcut way that we can do in knowing about perfect squares here. When this one says that if you've got two terms with a minus in between them this time in the bracket and the whole bracket is being squared, the answer follows this pattern. The first term gets squared to form the first term in our answer, and then that middle term has a minus in front of it, or a minus 2 in front of it. It's got a minus and 2 in front of a product of the two terms in the brackets together. So it's minus 2 lots of a, b there. And the last term in our answer is just the second term from the bracket getting squared. So if we follow that for our x minus 2 all squared, our first term is our first term of our bracket being squared. In this case it's x squared. Now have a look at our middle term here. It's minus 2 lots of x lots of minus 2 there, or anyway it's formed by 2 lots of x lots of 2. Turns out to be minus 4x there, trust me. And that final term of 4 for our answer is just gotten by adding at the end the 2 from the bracket squared. So that's a bit of a shortcut. It's tricky, but you can do it the long way if you like, but sometimes the question is based on knowing this shortcut way of perfect squares. So either way, doing it the traditional expanding method where we break up the brackets, or following this perfect squares sort of template, we get x squared minus 4x plus 4. Question 4. Expand 4x minus 2 in brackets times 5x plus 3 in the second bracket. Okay, for expanding brackets, I like to split the first bracket up, expand each section, and collect like terms. Alright, if we split this up, the first bracket, we're going to have 4x timesing by the second bracket and a minus 2 timesing by the second bracket, and we'll see where we are then. So we'll get 4x outside of the 5x plus 3 and a minus 2 outside of the 5x plus 3. Once again, when I see a minus in front of that second section, the minus 2 bit, I hold myself back and I go a little bit slower because it's a bit of a trap for young players there. It's a place where a lot of students go wrong. Alright, so let's multiply 4x by that first bracket. We get 4x times 5x, which is 20x squared. And when 4x multiplies by the second term in that bracket of 3, we get 12x. That second section, we'll do this a bit more slowly, Minus 2 times 5x makes minus 10x. Here's where we've got to be extra careful. Minus 2 times the 3 makes minus 6. We can merge the like terms there. 12x minus 10x makes 2x. So we'll get a final answer using our normal methods here of 20x squared plus 2x minus 6. Now this isn't a bracket being all squared here. It's just a normal expansion, so we don't have any perfect square shortcuts to think about in this one. Question 5. Expand 5x plus 3 in brackets all squared. Okay, we can split the first bracket, we can expand each section and collect like terms. That's the first way we can do it. And there'll also be a shortcut way talking perfect squares here for this question. So we can think of 5x plus 3, seeing it's being squared, we can think of it being 5x plus 3 multiplying by itself, or 5x plus 3 multiplying by 5x plus 3. So that's the way I like to do it anyway. And so we'll split that first bracket up. We'll get 5x multiplying by the second bracket, 5x plus 3, and we'll get a plus 3 from the first bracket multiplying by the second bracket, 5x plus 3. So if you spread it out there and do it nice and clearly, it should go pretty smoothly here. The first term by the first term in that bracket makes 25x squared, and the 5x in that first section multiplying by the 3 makes 15x. For that second part of the expansion, we have 3 lots of the 5x making 15x, and 3 lots of 3 makes 9. We can collect like terms here by going 15x plus 15x for the middle, and we'll end up with a final answer of 25x squared plus 30x plus 9. So that's doing it the traditional way. But it's also a single bracket being squared, which fits into what we call a perfect square shortcut, or I like to call it a shortcut. So it says the first term gets squared, and we multiply the first term times the second term by 2 to make that middle term of our answer, and we square the second term in the brackets. So if we applied that to our 5x plus 3 all squared, we'd have a look here. We've got the first term squared, and we'd have to be a little careful here. 5x squared is 5x times 5x, making 25x squared. This middle term is going to be a bit of a jumble. We've got 2 lots of the first term, lots of the second term to form that second term in our answer. So 2 lots of 5x times 3 will give us 30x for that second term. And the final term, the 9, came about from squaring that second term in the brackets. So following that pattern, we also get 25x squared plus 30x plus 9. I'd encourage you to learn that perfect squares method. A, it can save you time, but B, you can answer questions that are specifically on that knowledge. Question 6. Expand 3x minus 2 in brackets all squared. If we split the first bracket, expand each section and collect like terms, we can consider 3x minus 2 all squared as being 3x minus 2 times itself, or 3x minus 2 in one bracket times 3x minus 2, and think of it that way. We can split that first bracket up, so we'll be looking to multiply that 3x from the first bracket through the second bracket of 3x minus 2, and minus 2, the second term from the first bracket, multiplying that through the second bracket of 3x minus 2. So it'll all look a bit like this. We've split up that first term and we've spread them through the second bracket here. Okay, 3x times 3x for the first bit will be 9x squared, and 3x times minus 2 in that second section is minus 6x. Now here we're going to have to be a bit slower here when this minus appears. It's a bit of a trap. So let's do this carefully. In that second section, we have minus 2 times the 3x, which isn't too bad. We get minus 6x. For this last bit, we must remember that we take a minus 2 from in front of the bracket and multiply it by another minus 2 from the second term in that last bracket. So minus times a minus makes a plus, and a lot of students miss that. Alrighty, so we can join a minus 6x and another minus 6x, making minus 12x to make a simplified version of the middle term there. But we end up with 9x squared minus 12x plus 4. And as you can probably predict here, there's also a shortcut method with the perfect squares. When there's a minus in between the two terms, notice there's a minus in front of that middle term of our answer. Be a little careful there. Anyway, if we apply that pattern to 3x minus 2, we'll get the same answer as we got in the previous bit by expanding it normally. The first first term of 9x squared came about from squaring the 3x. Got to be careful there. It's 3x times 3x. It's not just 3x squared. It's 3 times 3 times x squared, making you 9x squared. Middle term comes about by going 2 lots of the first term, lots of the second term. In this case, 2 lots of 3x, lots of 2. Ends up being minus 12x. There's a minus on it when there's a minus in the original question. And the final term is gained by just squaring our second term from our bracket. So 2 squared makes our 4. So in the end we get the same answer as we got from expanding traditionally, 9x squared minus 12x plus 4. Question 7. Expand and simplify x minus 3 times x plus 3. Okay, if we split the first bracket, something interesting happens here when we expand each section and collect like terms. You'll notice we have a bracket with a minus in it and a bracket with a plus in it, but other than the plus and the minus, the terms are the same as each other in each bracket. There's an x as the first term and a 3 as the second term. So let's see, something very interesting happens on this one. If we split that first bracket up, we've got x timesing by x plus 3 and minus 3 timesing by x plus 3. Let's have a look at what happens. When we have x times that second bracket, we have x times x making x squared and x times 3 making 3x. In that second part though, when minus 3 gets to multiply by that second bracket, we have to be a little careful there. Minus 3 times x makes minus 3x, and minus 3 times a plus 3 makes a minus 9. Don't get tricked by that sign bit there. Minus times a plus makes a minus. Okay, now this is the interesting bit. When you've got a bracket with a minus and a bracket with a plus, but otherwise the numbers are all the same and the letters are all the same, this happens. The middle terms tend to, or a matter of fact always, cancel each other out. Notice that you've got a plus 3x and a minus 3x. That leaves us with just the first section and the last section. We're left with x squared minus 9. Okay, so that happens there. We can just expand it normally and we'll suddenly realize that the middle terms, when we collect the like terms there, they'll cancel each other out. It's a bit of a shortcut thing here. Now we've got a pattern here that we can follow as well, the difference of two squares pattern. So we can say that when we've got a plus bracket and a minus bracket, and it doesn't matter what order those are in, it could be a minus bracket then a plus bracket like we've got in our question here. But in the end, that ends up being the first term of the bracket getting squared minus the second term in the bracket, or the second part of the bracket getting squared. And that's it. That's because it's so simple, because the middle sections, as we saw before, cancel each other out. So anyway, if we apply that to ours here, with an x minus 3 and an x plus 3 happening, we just square that first term, so that's x squared, and we put a minus in between it no matter what, and we square that last number in the brackets of a 3, and we'll get x squared minus 3 squared, which makes 9. So x squared minus 9 is our answer there, whether we expand it normally and have those two middle terms cancel out, or we follow that special shortcut template there of the difference of two squares. Question 8. Expand and simplify 4x plus 3 in one bracket times 4x minus 3 in the second bracket. Alrighty, you'll notice there that we've got 4x plus 3 in one bracket and 4x minus 3 in the other bracket. The numbers in the terms are the same as each other, and in one bracket we've got a plus in between them, the other bracket we've got a minus in between them. When you see that, you can expect special things to happen. But let's do it traditionally first. We'll do this two ways. We'll split that first bracket up, we'll expand each section and then collect like terms and see what happens. Okay, well, split that first bracket and we'll have 4x timesing by the second bracket plus 3 timesing by the second bracket. When we do that, we get 4x times 4x, making carefully 16x squared. 4x lots of the minus 3 is minus 12x. In the second half of the expansion here, we have 3 lots of 4x, making plus 12x. And we get a 3 times a minus 3, making minus 9 carefully. Now you'll notice again, when we've got all the same numbers but a plus in between and a minus in between, you get the two terms in the middle cancelling each other out. Minus 12x plus 12x ends up being 0. So that just leaves us with the first section and the last section, 16x squared minus 9. So that's expanding normally. We get 16x squared minus 9. Let's have a look at the fancy pants difference of two squareds type shortcut here. When you've got a plus bracket and a minus bracket and everything else is the same, we end up being able to square the first term, stick a minus between it, and square the second term and go straight to our answer. We have to be a little bit careful because our first term in this case is a 4x. So a 4x all squared is 4x times 4x, making 16x squared. Don't get fooled by that bit. So when we apply that template to our question here of 4x plus 3 in one bracket and 4x minus 3 in the other bracket, we'll just square that first term of 4x times 4x, making 16x squared for the first section. And we just take our second term of 3 and square that as well, with a minus in between. So we once again get 16x squared minus 9, following the difference of two squareds shortcut pattern. Question 9. Factorise x squared minus 16. Alrighty, we have a difference of two squareds shortcut where if we can express the first term squared minus the second term squared, we can write it out as the first term minus the second term in one bracket and the first term plus the second term in the last bracket. So let's see what we can do. Now we can't factorise any letters out. There's no letters common between x squared and minus 16, and there's no numbers in the first term that we can factorise out with 16. So we've got no choice but to follow this fancy shortcut of difference of two squareds. So let's desperately try and express 16 as something smaller being squared. Can you think of it? We have x squared minus, 4 squared. So once we can express it like that, we can write the x minus 4 in one bracket and an x plus 4 in the other bracket. So it's a nice little shortcut. As long as we can get one term getting squared minus another term getting squared, we can still successfully factorise something that doesn't look like it's got anything that's common between it. It's pretty cool. Question 10. Factorise 4x squared minus 9y squared. Now we've got a difference of two squareds shortcut template type thing to work with here, because as you'll notice, we don't have any letters that are common between 4x squared and minus 9y squared. We don't have any numbers that go into 4 and 9 nicely. So we can't factorise in the normal methods. When there's two terms like this, you know it's going to be following this difference of two squareds type process. So if we can express something as one term getting squared, the other term getting squared, we can write it out, one of them, one bracket getting a minus in it and one bracket getting a plus in it. Now it's not already in that format. You might think it is, but it's not. We need one term, the whole thing getting squared, and that 4 isn't getting squared at the moment, and that 9 isn't getting squared at the moment. So this is what we have to do. We have to turn 4x squared into something smaller, getting all squared, like 2x times 2x makes 4x squared. So we can express it that way. And in the second bit, instead of the 9y squared separately, we can make it a 3y both getting squared, or all getting squared. So notice that fits better into the a squared minus b squared, as in the first term all getting squared minus the second term all getting squared. So that's how we have to do it. So then we can just write out the first term minus the second term in one bracket and the first term plus the second term in the second bracket there. So we had no choice. There's no other way to factorize this except following this difference of two squareds type pattern, and we get successfully an answer for that one if we can put it in the right format carefully.